Hi, my name is Tanner Leahy, and I'm going to be talking to you about carbon dioxide sequestration using algae. Through CO2 sequestration with algae, we can solve a couple of major environmental issues the world faces today. Doing so would make current power plants less environmentally harmful because their amount of CO2 emissions would be minimized. Algae could be used as a carbon-neutral biofuel, which we have previously discussed in this semester. Algae can also improve air quality, which is continually becoming a bigger problem, especially in big industrial countries such as China and large cities such as San Francisco. There are two main types of systems. Closed systems that sequester carbon dioxide at the source of emissions, particularly big polluters such as power plants and factories. The algae is put into clear pipes filled with water that are attached directly to the flue gas stack. These systems are highly efficient in removing carbon dioxide, but are much more expensive because it requires a lot more infrastructure. The pipes are clear because they allow the sunlight to penetrate the algae and thus create a photosynthesis reaction. The other type is an open system, which are essentially ponds filled with algae. These are much less expensive, but not as efficient because they are not exposed to as much carbon dioxide. They also require the use of land, which as we sequester more and more carbon, adds up to be quite a lot. If we were to sequester all of the carbon dioxide emissions, it would take up approximately 4% of US lands. The only chemical reaction in carbon sequestration using algae is the photosynthesis reaction, which we are all very familiar with, where carbon dioxide and and water combine to form glucose and oxygen. As you can see, this takes in the greenhouse gas, carbon dioxide, and produces oxygen, which we are going to touch on later. If we produce a biofuel out of algae, it would follow a typical combustion reaction with a hydrocarbon and oxygen forming water and carbon dioxide. Now, this isn't good because carbon dioxide, which we were originally sequestering, is being emitted. But when you consider it with the fuels that are basically storage, it helps to lower emissions by keeping carbon neutral. So why should we choose algae and not other biofuels or carbon sequesters? Most importantly, it provides carbon sequestration and reduces power plant emissions, especially in closed systems, and vehicles' contribution to climate change in the open systems, which takes in the CO2 in a much more diffuse environment. Algae emits oxygen in its sequestration of carbon dioxide, so it's greatly responsible for the fresh air and adding to oxygen levels in the atmosphere. This helps by making the greenhouse gases and other bad emissions more diffuse in the atmosphere. Algae is also really good because it can clean wastewater, which is more economical, especially for poverty-stricken nations. This is being implemented to improve water quality all over the world in a more net positive way. Unlike trees, algae is highly productive and can double their mass on a daily basis. This means that it's taking in a lot more carbon dioxide than trees or other alternatives. So it is much more productive to other plants like corn or algae flourishes in all sorts of habitats, so we could grow algae using salt water or even wastewater. This means that we don't have to use our good sources of fresh water and we can instead use non-potable sources of water. Especially in California, where water is a very big issue, we can use salt water, which is unpotable to humans. Algae, because it grows in all these horrible habitats, makes use of arid or infertile land, or land that is deemed undesirable, such as the lands adjacent to power plants and factories. Current carbon sequestration methods are highly expensive and sometimes unreliable, as the stored carbon in the ground has been known to leak. By using algae, we can reduce carbon in a way that these are no longer concerns and is economically beneficial to the people who are removing the carbon from the atmosphere. Thank you, and here are my references.